My name is Seth Adams, and welcome to the Adams Good Science program.
What are you doing here? This is my show.
You said this episode is about atoms.
Adams with a T, not a D.
Mr. Adams.
Leave! Hi, my name is Eliot Berry, and welcome to the Berry Good Science program. Today's program is about atoms. Atoms are the building blocks of the universe. Everything you see around you is made up of atoms. Atoms are the smallest particles that we can interact with. But atoms aren't the smallest things we know of. We know that atoms are made up of three things: electrons, neutrons, and protons. The protons and neutrons are clumped together in the middle, forming the nucleus, a densely packed small ball that the electrons zip around, forming the electron shell, the outer wall of an atom. The protons have a positive charge, the neutrons have a neutral charge, and the electrons have a negative charge. Meaning that if there are the same amount of protons and electrons, the atom will be neutral. I'll explain what happens when it's not neutral later. Atoms are very small.
How small are they?
Well, they are 0.1 to 0.5 nanometers small. But really, who knows what a nanometer is? Ooh, I do! Okay, Elliot, go ahead. Well, 1 nanometer is 1 billion nanometers. That's getting us nowhere. Think of it this way. An atom is to a grain of salt what a whale is to a honeybee. Here's a bee, and here's a whale. Let's zoom the whale out a bit. And while that's super small, it's nothing compared to how small and empty my heart is. Oh, how small and empty the inside of an atom is, because it's mostly comprised of empty space. If you put a pin in the middle of a stadium, if that was the nucleus, the electron shell would be the first row of seats.
Wow!
I am not impressed.
You're doing great, honey.
Thanks, Mom! If you're interested in atoms, one might assume that you've come across this. This is a periodic table. It is a diagram of all the different types of atoms. One could call it the atoms family. Do-do-do-do. There are different groups of atoms in the periodic table based on their attributes. The groups being alkaline metals, alkaline earth metals, transition metals, post-transition metals, metal alloys, halogens, noble metals, and noble gases. I once punched a noble gas. It didn't react. What makes one atom different from another is the number of neutrons and protons, mainly because those two things never change, while electrons will sometimes flop from atom to atom. If an atom has 3 neutrons and protons, it will always have the same amount till the end of time, so it can't change lead to gold. Sorry, ancient alchemists. In this next section, I'm gonna say the word protons a lot. Here we go. Every different atom has a different number of protons. For example, carbon has 6 protons and lead has 82 protons. A proton is a proton is a proton. A proton in a copper atom and a proton in a neon atom is still a proton. Just the number of them that change. If you're counting, that's 9 protons, or fluoride. So, how do you read the periodic table? Well, at the top, you have the atomic number, which is how many protons it has. Then below that is the elemental symbol and the elemental name. Pretty self-explanatory. And then finally, the atomic weight. It's just how heavy the atoms are, because they can differ depending on how many electrons there are. There is a whole mathematical equation to find the atomic number, but I won't bore you with that. They told me I had to bore you with it. Here you go. Ooh, math. When an atom is not neutrally charged, it's called an ion. Atoms can become non-neutrally charged when they have less or more protons or electrons. How atoms can gain or lose electrons is all explained in my next video on chemistry and how electrons make friends, unlike me. Have you ever wondered how one figures out something complex? Well, when that something hard is atoms, it starts in Greece, not the musical, the ancient civilization. The first person to ever think of an atom was in 400 BC in ancient Greece, thought up by a philosopher named Democritus. He thought that if you started cutting something smaller and smaller, at a point you couldn't cut it anymore, which does feel like something a child would say, but I digress. He called those uncuttable things atomos, for the ancient word uncuttable, because duh. But no one liked Democritus's idea, so the whole thing is kinda moot. Anyway, the first real discovery came in 1808 by a man named John Dalton, who looked like this. He just kinda looked sad. He had the idea that maybe everything is made up of small things called atoms. Then he wrote a book about it, because this was before video. Then, 100 years later, everyone thought that atoms were solid, but then J.J. Thomason, no relation to the man who killed the last 3 Star Wars movies, he told everyone that they were wrong, and they just had things called electrons floating around it, and everyone just believed him. Fast forward to 1906, where Rutherford and Geiger fired alpha particles at a thin sheet of gold foil, and they saw that some of the alpha particles were bouncing back. That taught them that an atom was mostly made up of empty space. They figured that out because an alpha particle can easily go through electrons because they're so small and fast, but they can't go through the nucleus. That makes it bounce back. Back to the future! Now, remember my metaphor from before. If the nucleus is a pin in the middle of a stadium, then the distance between the pin and the first row of seats is the relative distance between the nucleus and the electron shell. Rutherford was also a wacky character, saying things like, all science is either physics or stamp collecting. Humph. He doesn't seem that fun to work with. Geiger, on the other hand, wasn't a horrible person. He was the co-inventor of the Geiger counter, which is used to detect radioactive atoms. One might assume that the other guy was named Counter. Also, the alpha particles didn't bounce back often enough to be a solid. So, Rutherford and Geiger assumed that an atom had a dense ball in the middle that they called a nucleus with spinny balls around it that they called electrons, and an atom was mostly empty space. Finally, in 1932, the neutrons were discovered by James Chadwick. But before he did, World War I happened, and he was sent to a prison camp, and he discovered that a popular toothpaste was radioactive, which is strange. One might assume that they would see their faces were melting off and think, maybe the 9 out of 10 doctors were wrong. Well, there we go. In the 1930s, the modern atom was discovered to have a dense nucleus with protons and neutrons, with electrons floating around it. Okay, recap. Atoms make up everything. Such big liars. Actually, they're quite small. So small that we can't see them with our naked eye. Imagine a bee, the nucleus, and a whale, a grain of salt. Atoms are made up of electrons, protons, and neutrons. Electrons have a negative charge, protons have a positive charge, and neutrons have a neutral charge. The number of protons and neutrons determine the type of atom. And there are 118 different types of atoms, all called elements. And they're grouped together on the periodic table. Hope you got all that.
Well, that's all for today at the Adam's Good Science program.
How do you keep getting in? We've locked all the doors. Well, that's all. Hope you enjoyed. This has been the Very Good Science program. I'll see you next time. Give it.
You tell us, Dick.